A warm welcome from Claritaz TechLabs. Today we would like to talk about natural language processing using Python. First, let us see what is natural language processing. Natural language processing is about developing applications and services that are able to understand human languages. Now let us look into applications of NLP, chatbot development, text classification, language modeling, speech recognition, caption generation, machine translation, document summarization. Today we are going to use NLTK for natural language processing. The Natural Language Toolkit (NLTK) is a platform used for building programs for text analysis. The platform is developed by Stephen Bird and Edward Loper in 2001. Now let us see how to install NLTK. You can install NLTK using pip install NLTK. Then download required packages. Now let us move on to various natural language processing techniques like sentence tokenization, word tokenization, stop word removal, stemming, lemmatization, parts of speech tagging, named entity recognition. Now we will check each technique in detail. First, let us start with tokenization. Tokenization is the process of breaking up the given text into units called tokens. We have two types of tokenization: sentence tokenization and word tokenization. Now let us look into coding part. We are using Jupyter Notebook for our coding purpose. First, import NLTK. Then import send_tokenize and word_tokenize from NLTK. These are the other packages we are covering today. Next we will check the code for sentence tokenization. This is our sample text. You can use any text for this. Send_tokenize sample text. This will tokenize our sample text into sentence tokens. Let us run the code and check the output of sentence tokenization. Now we got the tokenized sentence from our sample text. Our sample text got tokenized into sentence with separate boundaries. These are known as sentence tokens. Now our sentence tokenization using NLTK completed. Now we will move to word tokenization. Let us check the code for word tokenization. The sample text will be tokenized to word tokens. Let us run the code. So our sample text got word tokenized. Now let us move on to a technique called stop word removal. NLTK is having predefined stop words. This is the code for stop word removal. First let us run this code. This is the output. Now you can compare clean words and previous tokenized words. Some extremely common words which would appear to be of little value in helping select documents matching a user need are excluded from the vocabulary entirely. These words are called stop words. All these words and predefined stop words will be removed from your sample text. As I told earlier, Natural Language Toolkit is having predefined stop words. Now let us print predefined stop words in NLTK. This is the code. All words inside stop words will be removed from your text while applying this technique. Stop word removal is one of the most commonly used preprocessing steps across different natural language processing applications. Now let us move on to next natural language processing technique called stemming. Stemming is a technique to remove affixes from a word, ending up with a stem. For example, the stem of cooking is cook, and a good stemming algorithm knows that the ing suffix can be removed. We are going to see three types of stemming algorithms: Porter stemming algorithm, Snowball stemming algorithm, Lancaster stemming algorithm. Now let us move on to the coding part. Let us start with Porter stemming. This is the code for stemming. These are the sample words we are going to use today. Import Porter stemmer. Let us run the code and check the stemmed output. Going changed to go, Moving and moved changed to move. Next, we will move on to snowball stemmer. Snowball stemmer. We are using same set of sample words. Then run the code and check the output. The output of Porter stemmer and snowball stemmer is almost similar. Now, let us compare Porter and snowball stemmer. Snowball stemmer is an improved version of Porter stemmer, which is also known as Porter 2. Snowball stemmer slightly faster in computation time. Next, we will move on to Lancaster stemmer. Import Lancaster stemmer. This is the code for Lancaster stemmer. We are using same, previous sample set of words. Let us check the output of Lancaster stemmer. Lancaster is a very aggressive stemming algorithm. We are getting words which are not in a dictionary in Lancaster stemmer. So, we need to select stemming algorithms depending upon your use case. Now let us move on to lemmatization. Lemmatization is very similar to stemming, but is more akin to synonym replacement. A lemma is a root word, as opposed to the root stem. So unlike stemming, you are always left with a valid word that means the same thing. We are using WordNet Lemmatizer. Now let us check coding part of Lemmatizer. This is the code. Import WordNet Lemmatizer. Let us check the output of Lemmatizer. So we are getting base or dictionary form of a word, which is known as the lemma. Now let us move on to parts of speech tagging. A part of speech tagger is a piece of software that reads text in some language and assigns parts of speech to each word, such as noun, verb, adjective, etc. Now, let us look into coding part of POS tagger. Import POS tagger from NLTK. Let us run and check the output of code. So, now we got certain tags to each word in our sample sentence. Let us have a look into what are these tags. NNP, CC, VBP, VBG, IN, etc. These are the Pentry Bank project part of speech tags. Now we can have a look into complete list of POS tags used in Pentry Bank project. This is the alphabetical list of POS used in the Pentry Bank project. NNP is for proper noun, singular. CC is for coordinating conjunction. IN is for preposition. Now let us move back to our coding part. Now we need to check how to identify names, organizations and locations etc. in our text using NLTK. For that we have technique called named entity recognition. Next we'll move to the coding part of NER. This is the code for NER. We are using NLTK NER chunker. NE_chunk needs annotations to add named entity labels to the sentence. Next we will look into the output. So Stephen Allen is recognized as person. Claritaz is recognized as an organization. Now, let us have a quick recap of natural language processing techniques covered today. Let us start from the beginning. We started with tokenization. We have seen two types of tokenization: sentence tokenization and word tokenization. Our sample text got sentence tokenized in first step. Then our sample text got word tokenized. Next we moved to stop word removal. NLTK is having predefined and stop words. We cleaned our sample text using stop word removal technique. Next, we have seen stemming algorithms. Stemming is the process of reducing inflected words to their word stem, base or root form. Porter stemming, snowball stemming and Lancaster stemming algorithm. Next we move to lemmatization, usually refers to remove inflectional endings. Then we move to POS tagging to find the verb, noun, adjective etc. in a sentence. Then our last technique was named entity recognition, which help us to identify person, location, organization etc. in a sentence. Thank you very much for watching this video. This video is powered by Artificial Intelligence and NLP team at Claritaz TechLabs.